Hi everyone, and welcome to my presentation on open source license compliance with automotive grade Linux. I'm going to start off by telling you a little bit about me. I've been involved with the Yocto project since around 2013 and automotive Linux for the last few years as well. I work across the whole embedded stack, so that's bootloader, kernels, root file system, distribution policy, a bit of everything. I'm currently working as a principal engineer at Konsulko Group, and you can find us on the web at konsulko.com, and you can email me at the email address there. So since we're talking about license compliance, I need to start this off with a little bit of a disclaimer. So I'm not a lawyer, and this presentation is not legal advice. What I can give you is an overview of the best practices as I see them based on my experience as a developer and as an open source community member for several years. What I will say is if you're in any doubt about any of this stuff, consult an appropriate lawyer who understands your jurisdiction and understands open source licensing. So a quick outline of this talk. First of all, I'm going to be addressing kind of more general best practices as well as pitfalls to avoid. And this advice isn't going to be specific to automotive grade Linux. It's going to be fairly widely applicable to any type of embedded Linux. And then for the second half of the talk, I'm going to dive into the license compliance tools that are provided by Yocto project that can be used in AGL. And I'm going to finish off by outlining kind of ongoing and future work in these areas. So I suppose I should give you an idea of why we should care about open source license compliance. Well, if you're selling an embedded device, which is running some open source software, then this carries the risk of legal action being taken against you if this isn't done properly. So that's one reason why you should be doing license compliance properly. Another is that doing things the right way and ensuring that you provide full source code for things gives you good standing in the community, which can be really helpful when you're trying to work with upstream projects. The other thing I will say is that sources do often disappear from the internet. Even for quite popular open source packages, sometimes old versions do disappear. So you really need to be keeping your own copy of the sources anyway to help you with debugging and to help you satisfy some customer request for maybe a modification of an old version of something you've released. And if you make sure you're archiving all these sources that you use anyway, then that's one of the major steps towards being able to achieve open source license compliance. So when we talk about open source license compliance, the fundamentals really fall into two things that you need to do. Pretty much most open source licenses you need to be providing a copy of the license text and any copyright notices along with the software that you're distributing. These can be provided on the device, potentially in some sort of UI or about information visible from your device. They could be provided in the documentation, they could be provided on a website. The other thing for copyleft licenses, such as the GPL, you also need to provide complete corresponding source code. This is usually the thing that's a little more involved to do. This source code could be published directly alongside the binaries, or you could provide an offer letter to people telling them that you'll provide the source on request. So a key concept that I want to introduce is the idea of the distributed image. So this is the software image that is actually distributed. So if you're selling a device, this is the software image that's actually programmed into the device at the point at which it is shipped to a customer. If you're distributing via a software download, this is what is actually in the file that a customer downloads. So this is what you really need to be thinking of when it comes to license compliance, is not kind of the result of running a build, but what actually ends up being sent out to a customer. Now, the advice I'm going to give is you should really aim for a single command build. So this is one command that produces the final image as it is to be distributed to customers. And this is probably the most important best practice. It helps reduce human error in the build and release process. And once you've got as close as you can get to a single command build, the other main thing you want to do is make sure that you test your releases. So typically a build and release process is not a trivial thing. There's a lot of moving parts going on. So just like any other piece of complex software, this build and release process needs some tests. So these tests should do things like check that the release contains the artifacts that you expect it to contain. Look inside tarballs as well. If you expect, say, a license file to be inside a tarball, write a script that checks that. And when you're distributing sources to go along with your binaries, write some tests to make sure that you can rebuild those binaries from the sources that you distribute. And what I will say is, as far as possible, automate these tests. The other key thing that I will say is use your build system as much as possible. So this applies pretty generally, not just to Automotive Linux and Yocto projects, but to any other embedded Linux project as well. Build the image with something like Yocto project or Buildroot. You've got loads of tools here for license compliance. What you don't want to do is modify this image in a post-build script, if possible. If you do that, you lose access to those tools that are in your build system to achieve license compliance, and you can easily break your license compliance process by adding in some extra software in a post-build script. So by all means, you can move, you can copy, compress the image file after you've built it with the build system, but try not to add additional software in a post-build script. And this also applies to any sort of factory test or factory programming process. So what actually happens on the device between the stages of programming an initial image and then that device actually being shipped out to customers. So if you use something like on-device package management to install things that are used during your test process, it's very, very easy to break the license compliance process at that stage. So try to limit any additional data that is added to the device at this stage. By all means, add configuration data or calibration data during the test process, but try to avoid adding additional software. If you need additional software, try and include it in the actual image build itself. Many Automotive Linux projects include a mix of both proprietary and open source software components. And when we talk about license compliance, that doesn't just mean ensuring that we distribute the appropriate licenses or source code for the open source components. It also means ensuring that we're not accidentally releasing sources for any proprietary components. So you need to make sure you do some filtering. And when we talk about testing the releases, you should also test to make sure that you aren't accidentally releasing the source code for these proprietary components. And what I would say, it's often useful to have two images produced by a build system, one that is a pure open source image and one that is the open source image with the proprietary components that you may be using. And that just makes it a bit easier to test that the purely open source version can be rebuilt in whole from the sources that you distribute, and makes it easier to ensure that you're not accidentally distributing the sources for those proprietary components. Now, when we talk about distributing sources, we also need to make sure that we distribute patches that are applied to those source files before compilation. So watch out for hidden patches as well. So this is said scripts or similar tools that modify some sources before they're built that aren't actually a file with a file name ending .patch, but still go through the same process of patching some sources. So you want to make sure you include those as well as any patch files. And you want to make sure that you record the patch order as well, not just a jumbled directory of patch files. Make sure you actually record the order that patches should be applied to the source as well. Version 2 of the GNU General Public License is one of the most popular open source licenses you will find, and it's the license that's applied to the Linux kernel in particular. Now, this license says that you need to include the scripts used to control compilation and installation, along with the sources that you distribute. Now, I think the best way to achieve this is to include the full set of Yocto project layers and bit-baked sources that you're using with an Automotive Linux build. That ensures that you've got all the recipes for building individual open source components and for putting them together into a final image file. Now let's move on to talk about things you need to be a little bit more careful with. Docker is really quite heavily used at the minute and is very popular, but Docker containers are often built from a Docker file rather than from a Yocto project recipe. Now, a Docker file is not the complete corresponding source for a container image. If you've got some sort of from statement at the top of a Docker file that's basing your container image on some other container image, you might not even know exactly what is installed in this base image that you're using. Sometimes things are manually added to a container image without using package management, and that can make things very, very difficult. So what I would say is watch out when using containers in embedded Linux. It's a really good idea to build the container images with Yocto project if that's what you're using for the underlying system as well, which would be the case for AGL, as that will allow you to use all the license compliance tooling that we've got in Yocto project. Another thing to be careful with is precompiled toolchains. So the ARM toolchain used to be the Linaro toolchain. This bundles GCC, glibc, and a few other components as a cross toolchain for various targets. And the compiler itself may not end up in the final image, but libraries such as glibc do end up in the final image, and glibc in particular is covered under the GNU General Public License. So if you are using this, you do need to make sure you capture the corresponding source code for these libraries. And that may not be an automated process. It may be a case of manually making sure that when you download the precompiled toolchain, you also download the sources for that. So another thing to be wary of is the language-specific package managers you get with some modern programming languages like Node and Rust and Go. So these have package managers like npm and cargo. So these package managers often have issues when it comes to license compliance. They often don't support offline compilation well, which makes it very difficult to test that the sources you've archived can rebuild an image. They also might not offer an easy way to get the license text or correct sources for all the dependencies and libraries used by a particular project. So I recommend doing your own research here. I found that Cargo is fairly good, the package manager for Rust. I've also found that npm is fairly difficult, so they can be a bit hit and miss. I highly recommend doing some research if any part of your project is dependent on one of those package managers. So how about more traditional software that's built with Makefiles? Well, I would say watch out for Makefiles. Some of them do some pretty weird things. So I've seen Makefiles that use online services and online tools during the build process. I've seen Makefiles which download additional sources during the build process. And both of these would kind of bypass what we want to do for license compliance. Again, they'd make proving that you can rebuild a set of binaries from some sources that you've archived difficult. It makes reproducible builds difficult, and it makes license compliance difficult. So if you're dealing with third-party Makefiles, I would highly recommend reviewing them and trying to make sure that they do build offline and do behave nicely. So one unfortunate thing which you need to bear in mind is that the licenses given in various Yocto project recipes are just metadata that's been entered by the person who wrote the recipe. So this may be incorrect or incomplete in some cases. Metadata bugs happen just like any other bug. So what I recommend to address this is that you follow the stable updates to Automotive Linux and to Yocto project and any layers that you're using, and incorporate those stable release updates into your build. And if what you're working on is kind of a major commercial project, I highly recommend you do your own verification here. Fossology is a good tool that's widely used to do this. And if you do this, I recommend that if you do find any issues, you feed those back to the upstream projects so that they can be solved for everyone as well. So now I'm going to move on to talking about things that are specific to Yocto projects and Yocto project recipes as they are used by automotive grade Linux. And the first of these is a little bit of advice when dealing with the license metadata within a recipe if you're writing a recipe for your own custom components. Some tutorials online will recommend using the license equals closed variable to denote something as proprietary. Now this disables the license checks and verification that's performed by the Octo project and makes it more difficult to catch mistakes. So what I recommend is that you don't use the closed value for the license variable. Give your proprietary license a name and include this name in the license field. I also recommend avoiding setting source rev to auto rev in releases. This can be fine during development, but it can cause a lot of problems at release time. It makes it very, very easy to mismatch the binaries that are in an image with the sources that you're trying to archive, because if something's been pushed to a Git repository just before the final build for a release, the auto rev will pick this up, and that might not be the version of the sources that you expected it to pick up. And it also means that rebuilding the image using these recipes several months after release can give different results than it did at release time. So I always recommend set some specific version in source rev when doing a release. Now if you have a proprietary license that's used by more than one recipe within your build, then what you can do is you can set this as kind of a common license. You can modify the license path variable to include a licenses directory within your layer, and you can store the full license text of your proprietary license within this, give it a name. As I said before, use this name in the license variable within your recipes. And I would definitely say prefer this to setting the license to closed or proprietary. If instead you have a proprietary license which only applies to one recipe, you can use the no generic license variable to flag this up. And that lets you include the license text from a source archive rather than having to put it in a common licenses directory. I would highly recommend using this rather than ignoring warnings about a particular license having missing license text. It makes it far easier to audit and to capture license text properly during the build. Now let's talk about how you can actually provide the license text for an open source component of a project that's built using the Octo project. As we said before, many licenses require you to provide this license text and any copyright notices along with the compiled binaries. And there's a few ways we can achieve this within AGL. We can copy the licenses deploy directory after building an image. This might need some kind of pre-processing and post-processing, because if you build multiple images, then all the various licenses and copyright notices end up in that directory. Alternative ways of doing this are to include the license text in the images that you build. There's a couple of variables that we can set to achieve this, and this will result in the license text and notices being placed in the common licenses directory under /user/share in the root file system. You can also use the create license package process. This is slightly different. It places the license text and notices in the licenses directory under /user/share, but because it creates packages along the way, this provides an upgrade path for that license text if you use on-device package management to handle upgrades. Now how about providing sources? As we said before, some copyleft licenses require you to provide full corresponding source code, including any modifications, with the compiled binaries that are included in your image. And with the Octo project that's used by AGL, this is provided by the archiver class. So you can set a variable in your configuration to use this class, and you can choose the mode for this. The archiver has several modes available, whether you want to capture the original source code or whether you want to include the patched source code or various other options. And the archiver has several further configuration options. It's covered pretty well in the Octo project documentation. One of these options that I want to highlight is the ability to include shallow mirror tarballs. So for sources that are fetched from a Git repository, Typically, the mirror tarball is produced will include the full history of that Git repository, which may not be necessary. And to avoid this, you can set these variables that I've shown here in this slide to generate shallow mirror tarballs instead of full mirror tarballs. And on a recent project I was involved in, this reduced the size of our source mirror from sort of 7.5 gigabytes down to 1 gigabyte for a release. And it works very, very well with the mirror archiver mode. So when it comes to providing the build scripts and patches alongside your sources, I think the best way to achieve this really is to provide the Yocto project layers that are used to build your image. And publishing these either as tarballs or preferably as Git repositories is a great way to do this. If these are open source, you can add them to the layer index maintained by Open Embedded so that they're easy for people to find. And this works really well when you isolate proprietary recipes into one layer and any custom open source recipes or modifications to recipes in another layer, so that you can just release the open source components and not worry about accidentally releasing the proprietary ones. So one thing to bear in mind when providing these layers is to watch out for any changes made in the local.conf file prior to building an image. You could either version control local.conf, or you could capture this configuration file and any other sort of transient configuration files as part of the build to make sure that there isn't any configuration that is kind of just applied on a developer's machine and then lost afterwards. And I'd like to wrap up by talking briefly about the future work in this area. So one thing I think we need is better integration with these newer language-specific package managers, and this might actually require working with the upstream developers of NPM, of Cargo, and of other package managers to ensure that they provide the features that we need for embedded Linux license compliance. I also think it'd be great to see automatic generation of a simple plain text or HTML license document for an image. That would make it just a one-step process to produce something that go into sort of an about dialog box in a user interface or in the back of a bit of documentation to capture all the relevant licenses. There are some great third-party open source projects like the OSS Review Toolkit that we could integrate better with. And lastly, one thing that would benefit AGL would be license scanning and SPDX document generation for each actual upstream Yocto project release. And this would also help provide a feedback loop to confirm that the license metadata in Yocto project recipes is correct. Now, it isn't necessarily a trivial thing to do. It's quite a lot of work to do all that scanning for every release, but I think it is something we should be advocating for. So with that, I'm going to give the remaining time over for Q&A.